Right, for this tutorial I'm going to look at standard deviation. So I'm going to do two examples working through standard deviation and finding the mean. And then I'm going to do one final one where we're just asked to leave it in a slightly different form, in surd form. It's this one here. So if you are quite confident with standard deviation, this is going to be my last example. So just to leave it in a root b over 2 form and write down the values of a and b. So if you are confident, you might want to skip to near the end of the tutorial and look at that example. For now, I'm just going to look at this first example. The number of hours spent studying by a group of 6 student nurses over a week are 20, 23, 14, 21, 27, 24. Calculate the mean and standard deviation of this data. So I'm going to do this first. This second part where you're asked to make 2 valid comments to compare study times, this comes up quite often. I'm going to do this in a separate tutorial. So I'm going to keep the answer that I get here, and then I'm going to go through a few examples of actually making these comparisons and writing these sentences, these comments here. So for now, I'm just going to do the standard deviation and the mean. So the mean we find by adding all the data values up. So adding all of these up and dividing by the number that there are, and there are 6 different ones here. So we've got 20 plus 23 plus 14 plus 21 plus 27 plus 24 divided by 6. So it's good to show you're working for the mean. And just be careful, either use the fraction button or make sure to press equals once you've totaled them all up, or use brackets. Otherwise your calculator would just do 24 divided by 6 at the end. So either use the fraction button, brackets, or press equals once you've totaled them up. So here we've got a mean of 21.5. And that's your first mark, so we've found the mean. We now want to find the standard deviation. So on your formula sheet for National 5, you have the standard deviation here. I'm going to use this formula here. So for this, we're going to use the formula to help us build up a table. We're working towards the numerator when we're doing this table. That's sum of x minus the mean all squared. So using that, we're going to build it up by writing x first, then x minus the mean in our next column, x minus the mean all squared, so we're working up to it, and then at the end of that column, we'll be able to sum all of them up. The sum of x minus mean all squared, once we've got all of these data values to add up, and then we'll be able to just sub that into the formula. So going back to our data values, when I'm writing this table, I like to write the x values, their data values, in numerical order. So I'm going to do that. We've got 14 first, 14, 20, 21, 23, 24, and 27. And just check here that you have written down as many as you need. There are 6, so yeah, we have 6 here. If you miss a number right here, it can just mean you go wrong. You don't really know where you've gone wrong, so just be careful for that. So now we're going to do x minus the mean for each of these. So you start with 14 and you subtract 21.5. So we've got minus 7.5. 20, subtract the mean, minus 1.5. 21, subtract 21.5, minus 0.5. 23, subtract 21.5. We now go to positive. So when you write them in order, you know your first few are negative, then you go to positive and everything else will be positive. 24 minus 21.5, you've got 2.5. And finally, 27 minus 21.5, you've got 5.5. And a good thing to check is that if you sum all of these up, they should equal 0. Just means you've got it right so far and you're on track. So I'm just going to sum them up on my calculator. Equals 0. Adding them all up equals 0. We're on the right track. We're now going to square each of these terms. So we're squaring them so that we can make them positive. So just be careful not to put minus 7.5 squared like that into your calculator, as it will give you a negative value. Really, you need to put that negative number in brackets. If you get a negative number once you've squared something, you've done something wrong, so just watch out for that. So we've got 56.25. You can also just put in, you know that negative 1.5 squared is the same as 1.5 squared. That would just stop you definitely having a negative, so you could do that. 2.25. Or just make sure you put in the negative symbol in the brackets. (1.5 squared is going to be the same as negative 1.5 squared, so 2.25. 2.5 squared, 6.25, and then the last one, 5.5 squared, 30.25. Now here at the end, we're going to sum all of them up so that we can get our numerator in our formula. So 56.25 plus 2.25, 0.25, we have a sum there of 97.5. And that right there is the value we're going to use in just a moment. So copying the formula from the formula sheet. Standard deviation equals the square root of the sum of x minus the mean all squared, which is what we've just found, divided by n minus 1. So standard deviation is there, that's 97.5. Over n minus 1, we've got 6 data values, so n is 6. That's these, 1, 2, 3, 4, 5, 6. So n minus 1, that becomes 5. Your standard deviation, square root of 97.5 over 5. We have 4.415 ... And so our standard deviation, we're going to round to 4.4. Right, and that's your first example. I'm going to do one more example almost identical to that, and then I'll do one separate one. So if you're feeling confident, you can skip to the last example of the video. This next one I'm going to look at is from the 2014 National 5 past paper. Our runners recorded our times in seconds for 6 different laps of a running track. These are our times, ignore the scores. Calculate the mean of these tracks. And it does say show clearly all of your working. So even for the mean, we know that we're summing them all together. Just wait for that to go in focus. So for the mean, we're summing them together. So looking at the data values, we're going to do 55 plus 57 plus 58 plus 60 plus 55 plus 56 divided by 6. So I've just taken those 6 values, added them all up, and then divide by 6. So our mean is 55 . Right, so for this one actually we're going to have to round the mean. So 56.833 ... So I'm going to round the mean to 56.8. Right, our next step, it says calculate the standard deviation of these lap times. So again, using our formula from our formula sheet, we're going to build up this table to help us get this numerator here. So you start with x minus the mean, and x minus the mean all squared. Right, putting in our data values, I'm going to put them in numerical order again, so you can see them at the top there. So we've got 55 and 55. So 55, 55, 56, 57, 58, and 60, and then just check I've got 6. 1, 2, 3, 4, 5, 6. Alright, we're now ready to do each number minus the mean. So 55 minus 56.8, going to end up with negative 1.8. We're going to do that twice. 56 minus 56.8 is negative 0.8. 57 minus 56.8, we're going to have 0.2. 58 minus 56.8, we're going to have 1.2. And then finally 60 minus 56.8, we're going to have 3.2. Alright, Now, I said before that when we add these together, we're going to have 0. So let's just see what happens this time. Negative 1.8 minus 1.8 minus 0.8 plus 0.2 plus 1.2 plus 3.2 equals. And now this time we've got 0.2 rather than 0. Now the reason that this has happened is because back here with the mean, we've had to round the mean. So as long as you are still very close to 0, then that is okay. If you haven't had to round the mean, it should be exactly 0. If you've had to round the mean back here, we just know that when we total these, it's just going to be close to 0. It's not going to be quite as accurate because we've had to round. We're still okay. We're still very close to 0. Now we're going to square each of these terms. Just remember that your squaring has to be positive. So we've got 3.24, 3.24. So either put your brackets in or don't put your negative in. 0.64, 0.04, 1.44, and finally 10.24. Now we need to sum all of these up so that we've got the sum of x minus the mean all squared, which equals, so we have 3.24 18.84. And final bit, we substitute that in to our equation, which I'm copying from the formula sheet here. So we've worked out that numerator there under the square root, 18.84. We have 6 data values, so n minus 1 becomes 5. And our standard deviation, 18.84 divided by 5. 1.941 dot dot dot, which I'm going to round to 1.9. And that's you with the standard deviation. Right, so those were 2 straightforward examples of using the formula, building this table up, and then we're going to look at the part B in a separate tutorial, this bit where it makes you the comparisons. Now I'm going to look at one more past paper question. This one is just a little bit different because it asks you for the standard deviation in a different form, and instead asks you to write down the values of A and B at the end. So gym members are asked to fill out a questionnaire to rate the quality of service provided. They're asked to give a rating of scale of 1 to 6. The ratings given by 5 members are as follows. In its simplest form, the standard deviation of these ratings can be written like this: find the values of A and B. So I think that the reason we've got this is because it is in a non-calculator paper, so we're doing this non-calculator. So first thing we need to do is find the mean. So we've got 1 plus, I'll just put this down so you can see it, 1 plus 4 plus 6 plus 3 plus 6, all divided by 5. So summing the total up there, 20 divided by 5, which is good because it's non-calculator. Nothing with too many decimals. We've just got that the mean is 4. So we've got our first step. We then build that table up before and use your formula sheet if you need some support building that up. X minus the mean all squared. And as I said before, I like to write the data values in order, so I'm going to write down 1, 3, 4, 6, and 6. Right. As I said, this is a non-calculator paper question. So 1 minus 4, negative 3. 3 minus 4, negative 1. 4 minus 4, 0. 6 minus 4, 2, and 2. And then if you were to add that up, 2 plus 2 is 4, minus 1 minus 3, back to 0. So looking good so far. Now square each of these. Remember, these need to be positive. Negative 3 squared is 9. Negative 1 squared is 1. 0. 2 squared is 4. And 2 squared is 4. So we can now get to the sum of x minus the mean squared, which equals 9 plus 1 is 10, plus 4 is 14, plus another 4, 18. So we have it in this value now. Right, copying down the formula from the formula sheet. Standard deviation equals the square root of the sum of x minus the mean all squared over n minus 1. So standard deviation is the square root of, we've worked out that this is 18, over n minus 1, n is 5, so that is 4. So now we're actually looking at, if we go back to the question, we want it in the form a square root of b over 2. So we're starting to go into some of our third stuff as well here. So we know that this then becomes the square root of 18 over square root of 4. So if you're not sure that you can do that, maybe look at some of your thirds questions. Square root of 4 on the denominator we know is 2. Square root of 18, I'm just going to take that over to the side here. We need to simplify that third. So simplifying a third, you're thinking what two numbers are factors of 18 where one of them is a square number? And that would be 9 and 2. So we write it as square root of 9, square root of 2. Square root of 9 is 3, so that becomes 3 root 2. So substituting that back in, we've got 3 root 2 over 2. And then looking back here, we're supposed to have written it in the form a square root of b equals 2. And just be careful to answer the question, find the values of a and b. So looking at what we have, the form it's supposed to be in, you can see that a equals 3 and that b equals 2. And that is you ready to tackle standard deviation and main questions.